This is the 6.4 mini lesson. So it says consider this equation, and it's listed here. Keegan says that to tell if the expressions in an equation are equivalent, not just equal, you need to evaluate each expression for the same value of x. Evaluate the expression on each side of the equal sign for x is 2. So I'm going to break this in half. So I'm going to take this piece over here, 3.2, and I'm subbing in 2 for x. And I'm doing the other side here, 12.8 times 2 plus 21.6. 12.8 times 2 is 25.6 minus 21.6 gives me 4. Over here, when I multiply, order of operations says do parentheses first. Inside the parentheses, there's multiplication, there's subtraction. I have to multiply first. So 3.2 times 2 is 6.4. Still have to finish the parentheses. When I subtract these, I get 1. So negative 4 times 1 is negative 4. These are not the same. Are these expressions equivalent? No. Negative 4 is not equal to 4. So Jasmine says Keegan's method can prove that two expressions are not equivalent, but it can't prove that they are equivalent. So when I look here, it says, so equivalent is not the same as equal. What's the difference? That's what we're going to hope to find out. So explain why Jasmine is correct. Provide an example of two expressions that verify your answer. Okay, so there are expressions that might be equal but not equivalent. I'm going to write that down. There are expressions that might be equal but not equivalent. And here's my example. I'm going to say 3x, and I'm going to say x plus 4. And I'm going to say 4x equals 2. So if I plug 2 here, 2 plus 4 is 6. If I plug 2 here, 3 times 2 is 6. So these expressions are equal, but they're not equivalent. So Caitlin says there is a way to prove that two expressions are equivalent, not just equal. Use the properties and try to turn one expression algebraically into the other. So when I look here, I can't turn this into this. That doesn't work. So these are equal when x is 2, but they're not equivalent. So reconsider again the equation that we used in the beginning. Use the distributive properties to simplify the left side and to factor the right side to try to determine if the expressions are equivalent. So if I use the distributive property here, negative 4 times 3.2x is negative 12.8x, and negative times negative will be positive 5.4 times 4, 21.6, and then we have 12.8x plus 21.6. These are not the same. This is a negative, this is a positive. So there's no way that this side could be transformed into the other side. So they are not equivalent. So are the expressions equivalent? No, because neither can be transformed into the other. And will Caitlin's method always work? Yes. If one expression can be transformed into the other expression, then they are equivalent. There is another method to verify the equivalence of expressions. We can graph them. If their graphs are the same, exact same line, then the expressions are equivalent. So if you grabbed a graphing calculator and we put those two sides into our graphic calculator from above, this is what your graph would look like. It's not the exact same line, so I know that these expressions are not equivalent. So again, are they equivalent? The graphs are not the same. So the expressions are not equivalent. Which method is more efficient? This is kind of a personal opinion. I think a lot of times it's easier to solve it algebraically, but some people prefer graphing, so that's an optional